want a class silent. It's not like yeshiva that everybody screams his own thing. In class, the professor speaks, the others listen. So that's how. Okay. So anyway, I want to say a few things before we start. First of all, this is a presentation that is based on a tour I did recently in France. I presented this something like 10 times to different places in France, in the Paris regions and in Belgium, and Baruch Hashem, it went well. The goal of it is twofold. One, to kind of give some more boost for Emunah. We started with Bereshit, we talk about creation, we'll talk about some of the creations of HaKadosh Baruch Hu. A premise, I'm not a rabbi, I'm a scientist. And therefore, what I'm going to say is from a scientific point of view. Of course, I'm a ma'amin in HaKadosh Baruch Hu, but I'm trying as much as possible to just talk about on the scientific side. A second premise I want to say is that I try to say what I say that is understandable for 99% of the people starting age 10 or 12. Once in a while, just to make pleasure to some people who are being more advanced in science, I may say a few things that are more advanced. If you don't understand, there's no big deal. And we move on, okay? So what one understands. Okay, and so bottom line here, one thing is, one skill I don't have for sure is artistic talent. And this is my best work. If you see this is an eye, and it's an eye that looks at science. And when it looks at science, it implies the understanding that there is a creator. This is my best work, okay? So, okay, let's start. There's a quote I want to show you from a very amazing rabbi that helped me make teshuvah, even if I met him only once, many, many years later. It's the Rav Yosef Chaim Tzitri. He was the chief rabbi of France for 21 years, for those who know him. And he says something beautiful in French, but I promise to say this in English. So in English it's this. He says, nature is the modest veil of protection that Hashem extends over man so as not to force him to believe in God. So you understand? So God puts a veil of protection, which is called nature, which is something that is made in a way that is not forcing us to believe in him. Okay? Whatever this sentence tells to you right now, it's one thing. When we'll get to the end, I'll pass this sentence again, and it'll probably have a completely different meaning to all of you. And I want to start with another great rabbi, who for me is the greatest scientist of all times, is Rav Victor Miller. Okay? Rav Victor Miller, for those who know him, he was a baki. When he passed away, there was a hesped. Someone said, I didn't agree with everything that Rav Miller said. He was very harif in what he said. But how can I argue with someone who finished Shas over 100 times? And he was an expert in making us see on science, on scientific things, the hand of HaKadosh Baruch Hu. He wrote beautiful books that I really suggest you, Rejoice Your Youth, or Universe Testifies, which is just a condensed version of the scientific part of Rejoice of Youth. And a story that I heard was someone came to him once and he said, Rabbi, I have a scientific question. And Rav Miller said, okay, I need to go to the office and find the answer. So he went, he came back, they started to continue talking, and then the guy said, but I have another scientific question. Well, he said, I need to go to the office a second time. And then he comes back and he continued talking, says, and it came another third question, scientific question. At this point, Rav Miller said, I'm sorry, I cannot go to the bathroom a third time in a row. So this is where he had all his science books. And what he had, what was amazing of him, was that he could see really what scientists are very good at. They can give you equations, differential, very, but it's the detail. But to see the forest, this was his skill. Among the many gems, he said, one of them was the following. He says, the truth is everywhere, but few men are able to see it. And it's a very profound statement. And we're going to try to see a few things, maybe see a few examples together, see if we can see a little bit of the truth. And in fact, his recipe for acquiring true wisdom, in fact, in one tape he said that he looked at a flower for a long time. And I don't remember, honestly, if it was 20 minutes or 2 hours or whatever it is. But when he looked at this flower, he said, I reached the highest level closest to Ruach HaKodesh. He said, when he went to this. And his recipe was the following. He said, look at something very carefully. Look it carefully and then think about it. Meditate, understand it. He looked at the flower, he couldn't understand. He looked, why the color like this? Why it's the touch like this? Why it grows this way? Why it's etc. And then look more closely. And then think a little more. And repeat the cycle many times. When you do this, with anything in nature, you'll become in awe of HaKadosh Baruch Hu. It's automatic. Okay. Baruch Hashem. So what I want to do now is to talk a little bit about what we call orders of magnitude. So number of zeros. For example, Elon Musk has a bank account with something like 10 zeros after a number, right? So let's say put a 1 and he has something like $10 billion or something. My bank account has many less zeros than his, okay? So let's try to understand what order of magnitude. So for example, when we say order of magnitude, if I say 1,000 or 5,000 or 3,500, it's the same thing. It's basically 3 zeros, okay? So the Earth, for example, our planet, is something like 13 million meters in diameters, 13,000 kilometers, right? That's the diameter of the Earth. When we look at the person, the order of magnitude is basically a meter. So 10 to the power of 0. This is 10 to the power of 7. There are 7 zeros in meters. Then there is no zeros after. And then there are things that are very small that are like, for example, an ant is order of magnitude a millimeter, which means 10 to the minus 3, 0.001. 3 zeros and then a number, okay? So this is what we call orders of magnitude. And here, just from the ant to the Earth, if I take an ant and I multiply its dimension by 10 to the power of 7, right? Sorry, by 10 to the power of 10, I have the diameter of the Earth, right? Is it okay? So this is, we have 10 orders of magnitude between the ant and the Earth. Let's see if there is more in the creation of HaKadosh Baruch Hu. So there is an old video. It's a very old video, but I found it very, very nice. And I want to pass it to you. It talks about powers of 10. He's going to show you basically people doing picnic, and then he's going to go every 10 seconds, 10 times bigger, 10 times bigger, 10 times bigger, and let's see where we get, okay? Hold on a second, I need to put... Okay.
The picnic near the lakeside in Chicago was the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Powerboats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters. The distance an orbiting satellite covers in 10 seconds. Long parades of clouds. The day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1 million meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide in their big orbits. That outer orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, Our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the clouds of Magellan, 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home.
10 to the 24, and in fact we went even, this is a 1977 video, it's quite old. So it shows you, well, we are kind of a meter, and this is something like 100 million light years. 100 million, meaning light that goes at 300,000 kilometers per second would take 100 million years to do the distance of this width of the universe. So, and Hannah, when she pleaded with HaKadosh Baruch Hu for a child, she used it, said, listen, Hashem, you created so many things. You created such a humongous universe, and you cannot give me a son. You know, this is, but let's look more closely at our, let's go back a little bit on our solar system. We are something like 150 million kilometers from the sun. And what is fascinating is that if you look at all the planets, we are the only one that, first of all, has a temperature that is suitable for life. Well, when you get too close, it's too hot. And when you go to Mars and company, it becomes too cold. So this looks like too much even for the ones who want to have some suntan. That's too much for 160 degrees. And when you go to Mars, it's minus 58, which makes Siberia look like a summer camp. But one thing that is fascinating is that not only we're at the right distance, we have also the right atmosphere. So first of all, the atmosphere that we know has 21% oxygen, right? Why not more? When someone, lo alenu, is sick, goes to the hospital, they give more oxygen, right? Why we don't have more? HaKadosh Baruch Hu made a chesed that is unbelievable, and few people know, is oxygen is a gas that makes other things more flammable. And the limit, the flammability limit is 23.5%. Meaning when you get to 23.5%, things would get flammable very easy. And that's why in hospitals there are unfortunately it's easier to get fires in there. So Hashem gave us the maximum that is safe. And the other plants, by the way, either don't have an atmosphere or have an atmosphere with something like 95% or plus of carbon dioxide, which is basically if you stay under a car and breathe the exhaust, that would be what you would feel how you would be in Venus or Mars. So it's not really very conducive for life. On top of that, this atmosphere, look at this. You see this little thing? It's like for an apple you have the peel. This tiny peel is the one that gives us life, because it does many things. Not only it has the oxygen in there that we can breathe, it also protects us from UVs, ultraviolets, and other harmful radiations. And also another thing, I know Avigdor Miller says this in his tapes, is you notice that the moon has a bunch of craters, right? Why? Because there are a bunch of asteroids and other particles that fly in space and that collide with the moon and make a crater. Why we don't have the craters? Because the asteroids and company, they enter our Earth, but they get burned by friction into the atmosphere. By the way, it's a very, re-entering the Earth is one of the big problems. For example, the shuttle, they had to engineer the shell in a very special material to sustain the heat, enormous heat, from friction in the re-entry into the atmosphere. So we see exactly, we are the only planet that has exactly the right conditions, the atmosphere, the temperature, and everything else, and we can go on. There's something called fine-tuning. I don't know if you heard about this term, fine-tuning of the universe. If you look at all the constants of physics and chemistries, all the phenomena, all the synchronizations, etc., all the cycles, they're all exactly designed for life with very, very tiny tolerances. We'll see a few today. Okay. And in fact, we say, Bishvili nivra olam, HaKadosh Baruch Hu has done this for us. I read something very nice, but it's in a book from a rabbi that we wouldn't call orthodox, so I'm not going to cite the rabbi who said that. He said something very nice. He said, we have to have two pieces of paper. One, that we write Bishvili nivra olam, we put it on the right pocket. And then another one, Ani afar va'efer, and we put on the left pocket. If we feel very, very gavadik and so on, we take the one Ani afar va'efer, we calm down. And if we are very depressed, we don't feel good, we take Bishvili nivra olam, and it kind of boosts our mood. So it's an interesting etzah. Okay, I hope the rabbi will maskim on this. No. Hasidic support, perfect. Okay. Okay, so this is our Earth, and well, it's a big Earth, right? Very big Earth. But when we look in comparison to other planets, well, the Earth is here. Well, not so big Earth. And when you compare it to the Sun, well, this is the Earth. Huh? This is the Sun, this is the Earth. And so it makes you think, where are we? Who are we? So, I'm sorry, I don't want to depress you. It will get a little more depressing even more, but then we're going to try to get up, okay? So it's really, when we think about this, Hashem has done all this for us, and who are we? Right? It's going to get worse. Okay, this was my favorite toys, Lego. Let's talk about Lego. Lego, when you think about this, how is Lego working? You have a few dozen types of parts, right? You have the long one, the short ones, the 4, the 2, etc., right? And how many pieces you have? Usually for doing something, you need a few hundred or sometimes 1,000 if you have a lot of money to buy the big Legos, right? The train or the car or things like this. And then you can do houses, trains, car. You know, I think everybody played with Lego, we'll all enjoy. So this is the Lego that we have. Well, HaKadosh Baruch Hu also has a Lego. And I know, please, I don't want any heart attack in the room. I know when we talk about periodic table of the elements, chemistry, people start having palpitations and spasms and epilepsy crisis. And no, it's not that terrible. We're going to just touch about it. But that is just enough for understanding it. And basically, when you think about it, it's like the Lego. You have a few dozen types of elements. Really, even if you have 100 here, the ones that are really useful, something like 3 dozens or so. And then, how many? Here, billions and billions of elements in any physical object, not coins, it means translation. Anyway, so why? Do you remember there was an Italian scientist that said how many we have, for example, in, let's say in a centimeter cube. If I ask you how many atoms there are in an egg, we're going to talk about an egg today. How many? Order of magnitude. Wow.
120.
Billion. Anybody heard about a guy called Avogadro? Amedeo Avogadro? Avogadro said, okay, very good, at least one. Very good, thank you. Thank you very much. So, order of magnitude, 10 to the 23, 10 to the 24. 10 to the 24 means a million of atoms in an egg, for example, right? This is a big number, so much more than Legos. And the final object is everything. We can even do Legos with atoms, right? Everything is made of atoms. We are made of atoms. We're going to talk about that. And how does it work? Well, every atom contains, okay, so now let's be clear. An atom has 3 things. There is, in the nucleus, in the center, you have neutrons and protons. Neutrons don't have a charge. Protons are positive. And they're all concentrated in a very tiny center. And then very far away, you have tiny things that are negative, as called electrons. Just to give you an idea, if the nucleus was a ball here, a balloon, a soccer ball, the electrons would be somewhere in big, right? So there is a lot of emptiness in the atom. You have a centered nucleus and you have electrons very far away. But everything is neutral, meaning you have the same number of positive protons and negative electrons. Rabbi Ephraim Watzman said something beautiful in one of shiur. He said, we always say Hashem is mezavek zivugim. And we always think, okay, he takes this man and this woman and he makes a shidduch and it's a wedding, right? He said, no, that's not what it means. It means for every proton, he takes an electron and he pairs them up. Because if we had a bunch of electrons in one hand, it would make such an electromagnetic disturbance that the world would topple over. So, but Hashem made that there is always an electron and a proton that are paired together, okay? And in fact, how you build this table, you take, for example, hydrogen, you have one proton and one electron, and then your next one is helium, you have 2 protons and 2 electrons, and then lithium, 3 protons, 3 electrons, vechule, vechule, okay? Very simple. So neutrons and protons in the center, very far away, the electrons. That's the Lego of HaKadosh Baruch Hu. And each one is special. And I want to show you some examples of how much more special the Lego of HaKadosh Baruch Hu is compared to our Lego. Okay? Let's see some examples. So before we do this, I want you to understand how small is small. So we're going to take the same video, and now what he does is going to go on reverse. It's going to go onto the small. So let's have a look how small is small. And then we're going to talk about the atom.
1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand. In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus, so massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding. Are these some quarks in intense interaction? Our journey has taken us through 40 powers of 10. If now the field is 1 unit, then when we saw many clusters of galaxies together, it was 10 to the 40th, or 1 and 40 zeros.
Hashem takes care of everything, from the tiny to the big wig, right? He says from the horns of the ram to the lights of the night. By the way, I want to show what we always say, Hashem is pi din al chut ha'se'ara, right? There's like a splitting of the hair, like the thickness of the hair. I think it's a tremendous rachamanut when you think about this, because the hair is something like 50 microns, which is 50,000 nanometers, which is basically something like 500,000 atoms in size. So he could have been much more precise and go much more deeper, okay? But that's just a scientific comment. Okay, so bottom line, we span something like 40 orders of magnitude or even more when we go from the atom to the galaxies and the whole universe. 40 orders of magnitude. I don't know if you realize what it means. From something that is 1 to something multiplied by a number with 40 zeros after that. That's tremendous, the power of HaKadosh Baruch Hu to go from the tiny, and they all work together because the whole thing depends on the single atom, right? So, and if you look at our body, the human body has something like 10 orders of magnitude inside, because you can go from the atoms, they are 10 to the minus 10, or the angstrom, and you go to the DNA, you go to the cells, and you go to the organs, and you go to the systems, and you go to the human, and basically you also have, into us, we have just around, in us, we have over 10 orders of magnitude. It's pretty impressive. And I want to show you how much more special those Legos of HaKadosh Baruch Hu are compared to our Legos. Because our Legos, when I take a blue and a red, and I put them together, I have a blue and a red, right? But here, there's something very funny that is going on. I want to show you a few examples. So first example, I can combine atoms and have very surprising product. Example. Now I'm going to show you here sodium. Sodium is a soft metal that burns and explodes in water. Look at this. Okay, that's with sodium, right? You don't want to mess up with sodium, right? Another example is chlorine. Chlorine is a gas that is extremely toxic, and it was developed by, sadly, a Jewish scientist, Fritz Haber, and it was the first chemical warfare during the First World War. And they used it, the Germans used it against their enemies, and it's a terrible gas. It makes terrible damage to the person until the person dies. And this was an explosion in Jordan, so maybe we shouldn't be so sad about this. Some 14 people died, and who knows how many more, whatever, were injured. But the point is, this is a terrible gas. Just a parenthesis, which is very sad. And this is, we'll see, unfortunately, in many Jewish scientists are not really, well, whatever, I don't want to say anything. Fritz Haber is the one who invented Zyklon. I don't know if you realize. We know what Zyklon B was, what's just the modification of Zyklon that he invented. A Jewish guy did it. So it's Hashem Yerachem. So anyway, so you have those two things that are terrible, chlorine and sodium. And if you say Lego, I'm not playing with those Legos. I don't want it. But you know, if you put them together, sodium and chlorine, you know what you get? Salt table that you use every Shabbat on your challah, right? So it's amazing. You take two things that are terrible, you put them together, you have something amazing. Okay. And someone's asked me a question, hold on a second, but when you put the salt in the water, it separates the chlorine and the sodium, right? Yeah, but then they are solvated by the water molecule around. And the one said, but hold on a second, so you have the sodium with the water, sodium and salt water, which so it explodes. Magically doesn't explode when you dissolve it like this. So it's interesting, you can go deep. That's another example. This molecule, anybody knows what it is? Okay, I don't expect anybody to know. There was a film, but it's a French film. In English, it's called the Salary of the Fear, or The Wage of the Fear. And it was a film where they had to transport nitroglycerin. Nitroglycerin is a kind of a liquid solid jelly kind of thing that if it drops, it has a mechanical impact, it explodes with really, really nasty consequences. This film was basically transporting nitroglycerin to explode a well of petrol that was getting fired and so on, and it was a terrible film. Anyway, very tragic, tragic film. And basically, the thing that is fascinating is that the elements that do nitroglycerin are hydrogen, carbon, nitrogen, and oxygen, the same that we have in the DNA, right? So very nice Lego pieces, but you put them in a certain way, you get something terrible, right? Carbon and hydrogen basically is the basis of life. Oxygen, nitrogen you have in our atmosphere. So very, very common, nice elements. You put them together in a certain way, you get something terrible. Let's see more. How the atoms are arranged. For example, carbon. You know, carbon, you can have this thing. You do your barbecue. It's black, it's soft, it's very cheap, and it's an electrical conductor. And then there is another variant made of the same atom, which is this one, that for some unknown reason to me, it's only among men here, women like a lot this type of kind of stuff, right? It's transparent, it's very hard, very, very expensive, and electrical insulator. And what is the difference between the two? It's all carbon atoms, this one and this one. Well, the difference is that these ones, the atoms are arranged in a certain way, and down the diamond, they are arranged in a different way. By the way, I didn't know how to say or not, but just to relax the atmosphere, because we went down a lot on the when we understand now that we are nothing in the universe. Just to say a joke like this, there is a story of a guy and the husband and wife, and they're in an American mall. You know, there's huge malls that have hundreds of stores and so on. And at some point, they lose each other, and they can't find each other. So the wife calls the husband, says, "How, dear, where are you?" He said, "Darling, do you remember the jewelry store that had this diamond ring that you liked very much, and I promised you that one of these days when I have the money, I'm going to buy for you? Do you remember that?" And the wife said, Yes, darling. Yes. Yeah, okay. And so the husband says, yes, I'm in the sports store across from it. Okay, anyway, so that's for that. Okay, so and our DNA is made again of those same things. There's maybe some phosphate on it. By the way, the DNA, even Bill Gates said it's like a computer program, but much, much more complicated than any computer program we've ever done. We're going to talk about that later. So let's go back to our atom. Our atom has a nucleus that has protons and neutrons. Protons are positive, neutrons are neutral. And this thing is kind of dimension 10 to the minus 15 meters, femtometer. Very far away, 10,000 times away, meaning if I have a balloon here that is the nucleus, my electrons are somewhere in big or further, right? So, and those electrons are tiny and are charged negatively. So questions. So first of all, as many protons as electrons. Okay, the diameter of the atom is 10 to the minus 10. We call it angstrom, which is a tenth of a nanometer. But the nucleus is 10 to the minus 15, so 10,000 times smaller than the atom itself. So there is a bunch of emptiness. Now I want to ask you a couple of questions. You all remember in school that positive and negative attract, and positive or negative and negative repulse, right? You remember that? Okay. So I just told you that I have a nucleus that is very tight with a bunch of protons and neutrons that are close together. How is it possible? Proton and proton don't like to be together. They want to just go away. How come? Well, there is something called nuclear force, strong and weak nuclear force, which is a force that acts only at very, 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 very short distance there. And what is amazing, scientists have studied, if this force was 1% stronger or 2% weaker, we wouldn't have atoms, we wouldn't have life, we wouldn't have anything, because the nucleus would either implode or disintegrate. Another question I want to ask you. We have electrons that are negative, and the nucleus is a bunch of protons, so it's positive, right? Positive and negative, what do you remember from school? They attract each other. So the logical consequence would be that the electron should go and smash on the nucleus, and it would be game over for everything. But it doesn't. Why it doesn't? Well, there is something called Bohr postulate. Niels Bohr was a Jewish scientist of the quantum mechanics revolution. And Bohr said it's a postulate. You know what postulate means? It's like this, shut up. That's what it means. Postulate, we don't know, but it's like this. So bottom line, the electrons don't smash on the nucleus, and that's it. Don't ask questions. And I want to tell you more. Sometimes, so there is a force, electromagnetic force between the two, right? Inversely proportional to the square of the distance. So that force, if that force was 4% weaker, we wouldn't have atoms, because the electron would just go away. And if it was a tiny bit stronger, I don't remember how much. So bottom line, Hashem has made things with tolerances of 1%, 2%, 4%. Do you realize that? All things are there in such a precise way that it's absolutely unbelievable. Unbelievable. Very tiny percentage. Okay. But the point I want to make is this. The atom is almost completely empty. 99.99% and more is empty space. So let's make what we call a Gedanken experiment. An experiment where we say, okay, if I take, for example, I take my Earth. We said it's 13 million meters. And if I've made some assumptions of which atoms it is made of, and I said, let's put the electron on the nucleus. Let's eliminate all the empty space. How big would the Earth be? Do you know how much it would be? Not exactly. It will be something like half of the Eiffel Tower, according to some assumptions. Maybe 10 is body. So bottom line, this is unbelievable. It would be, but still with the same mass of the Earth. So this 10 to the 24 kilograms. By the way, Gustave Eiffel has an odd bilevado. So we are nothing. Not only we are nothing of nothing, we are even empty. So us, if you said, let's take the empty space between electrons and the nucleus in our body, would not be a speck of dirt. Sorry, I don't want to depress. Okay, we're gonna try to but before, okay, so anyway, I told you this thing, and now we have to meditate about this concept. But before, I want to tell you one thing. Gustave Eiffel, he was an alumni of a very prestigious university called the École Centrale Paris. And when you look at the Wikipedia side, and you see the famous alumni, you have something less than 50. Of course, he's there because one of the first. And then if you look lower, you see also my name in there. Okay, and in fact, I went also to the Polytechnico in Milan, and if you do the same thing and you go to Wikipedia, you see there are two names. One of them is Giulio Natta, was Nobel Prize in chemistry, invented plastics, and then there is my name also there. So, but what do you learn from that? Why did I present this thing? I want to teach you two lessons. First of all, professors sometimes don't understand what they're talking about. I just told you we're nothing, a speck of dirt, and I'm here kind of gavadik on my things. The second thing is, if you're looking for someone humble, don't look for a professor. Okay, Rabbi Genish knew already, but that's another thing. Okay, so let's go back to our atoms, okay? So we have atoms. We can do amino acids, DNA, chromosomes, cells, organ, tissues, living being. Maybe we can build, we can build a human being. Like, give me all the Legos. I put all the Legos exactly, and I do them, right? But let's understand, what is life? Life is all the phenomena that we say growth, metabolism, reproduction, that all organisms, animals, and plants present from birth to death. Well, for example, Lego is not alive, because Lego doesn't grow, doesn't consume any energy, and the Legos I had when I was a kid, they're still there. They haven't multiplied. There's no reproduction there. Okay? So those are the key things that define life. And what is death? The definition of death is the absence or cessation of these phenomena, ending of these phenomena. So the difference between life and death is when you have life, you have growth, metabolism, reproduction, and death you don't have. But let's think about it for a second. Lo alenu, someone dies. Okay? A few minutes before, an hour before, he was made of certain atoms, right? And then the person dies, and it's exactly the same atoms. Why one is alive and one is dead? It's exactly the same thing. The living and the dead have the same atoms in the same place. I just told you how important, how things are distinguished by which atoms they have, where they are, how they are connected. So they're all atoms. The atoms are exactly the same between the live and the dead. So how come the dead is dead and the live is life? So from there we need to understand, we know that something is missing. Okay, in science we don't know how to define this. We know the answer. What is the answer? Is there is more than, it's not only organic materials contain carbon, right? Oh, it's an organic material. Yeah, also whiskey is an organic material, but it doesn't reproduce, it doesn't have metabolism, right? For some people maybe it does, but anyway. So, but we have a neshama. That's where we bring this Lego to life. We don't understand exactly how it works, right? There are even some scientists that you may have read about this. They wanted to measure the weight of the neshama. So they have a person about to die on a scale, and I think it's total nonsense. I'll tell you why it's total nonsense. I have in my lab a scale that has 4 zeros, meaning you have 0.0000001 grams. And this scale is so sensitive. Any speck of dirt, of dirt, and the scale is to throw in the garbage. So to put a person, kind of alive, dead, on a scale that has this kind of measurements, it's total nonsense, in my opinion. Okay, anyway. So what distinguishes the live from the dead is the neshama. Because otherwise, from an atomic perspective, from a scientific perspective, they are exactly the same. Okay, after a certain point, there will be some putrefaction phenomena, other things like this. But I'm talking, let's say, plus minus 2 hours of a person. That's one thing. And the result tells us that even inanimate objects and plants have a soul. The University of Tel Aviv did a study on plants. They measured plants' reaction in the ultrasound, and they were able to see that plants emit signals in the ultrasound regime of different, if they were about to be cut or to be kind of put some water on it. So clearly there was this. And in fact, this seems to be consistent with our learnings. We said, for example, and this is from Masechet Sanhedrin, it says during the second hour a golem was crafted, and during the fourth hour the neshama was breathed into it by HaKadosh Baruch Hu. You know, there's this joke, there's an atheist scientist that goes to Hashem, and he says, Hashem, we don't need you anymore. We know how to do man. Oh, God said, wow, you can, so show me, please. So the scientist bends down to take some dirt, and God says, you use your own dirt. Okay? So we are also dust and neshama. We know that neshama shenatata bi tehora, and we know that at the end of the day, the dust returned to the dust. But bottom line, we are the neshama, and at the end of the day, the physical part is really the speck of dust when you think about the atom and the emptiness. That should make people think about this. Let's see one example here. I want to show you two examples that I like very much. And I've shown that something like 4 years ago but I think I understand from Rabbi Chatzera after 4 years we can represent the same thing. So I want to show you an example about the egg. The egg is a closed system with inside two liquids, the yellow and the white, right? And you put them for 21 days under a hen or in an oven at a certain temperature, and then you have a chick coming out, right? So let's have a look about this process, and then let's talk about it. "21 days. And this is the day in here at the very beginning, at the embryo, it starts, the first thing is the heart. So it tells you here what's going on. Cool, right? So let's think about this for a second. So you have this closed system with those two liquids, and then you have a chick that comes out. Let's think about it first as a chemist. As a chemist, you say, hold on, there are atoms that are in the two liquids. How many atoms? We said 10 to the 24 order of magnitude, right? So a bunch of atoms. And they are the same atoms that will form the chick, and also the food that the chick will eat during the whole incubation period, right? At the end of the day, when you finish, there's almost nothing remaining. So everything is calculated exactly. You buy your Lego, and you have your Lego exactly with the right pieces, do your train. You know, I often challenge people, I'll say, you know, what is this? It's the same as I said to you, anybody wants to take the challenge, I give you a Lego of 300 pieces in a big transparent box. All the pieces are there, and I want you to do the Lego. Who wants to take the challenge for $1 million? So you know, professors lie because $1 million is a professor. It's a joke, right? Anyway, so but I said one condition: you cannot open the box. You can only shake the box. Shake the box until you have the train station done. Why shake? Because heat. The hen, what it does, it sits on the egg. It just heats. You can do the same thing by putting the egg on an oven at a very specific temperature, right? So the heat is what helps to do those chemical reactions. So it's just molecular agitation in there, and that helps to make so the heat it's only heat that it does, and it does this. But everything is exactly calculated so the two yellows have exactly the right types of atoms, carbon, oxygen, nitrogen, etc., that will be used, exactly the right pieces that will be used for the chick at the end. When you look at this from a material scientist perspective, it's a different thing. You can say, hold on a second, I have two liquids in there. And then at the end I have some things that are hard, like a beak. I have some jelly parts like the eye. I have some hard claws. I have feathers that are kind of soft. I have a bunch of materials that come out from two liquids in a closed system with no connection to the outside. How is it possible? So the question is how do they form all the parts? Where's the intelligence on this? And I want to spend one word also on the shell. The shell is amazing. The shell has to withstand the weight of the hen during the incubation, right? So it needs to be hard. But at the same time, it needs to be not too hard, because otherwise the beak cannot come out. You know what's going on? during the 21 days, the thickness gets reduced. Pele, atzum. The thickness of the shell is a certain thickness, and over time becomes thinner and thinner and thinner, so at the end the cheek can pick on it and get out easy, otherwise you wouldn't be able to out. So it's amazing. There's a scientific paper on this, fascinating on this story. And on top of that, I just told you before, sometimes professor can cheat you like crazy. You don't even realize how they cheat you. I just said it's a closed system without connection to the outside. That was a lie. Because it's a nanoporous shell. It can let air and moisture in, but not the rest. So when you analyze carefully the shell, it's not a closed system. It allows some things in. Voila. And also another thing, the shell is so complicated that it takes 21 hours inside the hen to be formed, but the yellow and the white take only 3 hours. Every 24 hours a hen gives an egg. So, and by the way, the shell mechanics, the shape has been used by construction engineers to do shells and things like this, because it's a shape that is absolutely great to distribute the weights. Amazing chokhmah that we see in this. And if you go to the human being, you know, we work a little different. When the baby's inside, there is something called the placenta. I know that, you know, everybody who had a baby has this brown thing that comes out after the baby is there and it's in the box, and then we think, a piece of meat, right? This placenta is magical. It's amazing. The placenta is doing all the functions that the baby cannot do inside, because the baby cannot breathe. It doesn't have liver function. It doesn't have, the circulation is done by the placenta. The placenta is doing a bunch of things. And what is even more fascinating is that the baby, when he's inside, the placenta is taking over. And there are a few things, like for example, 3 valves that are either closed or open during the time inside. And then when the baby comes out, they switch. For example, there's a hole in between the 2 chambers of the heart that if we had this, we would go to the hospital on the spot with big problems. But as soon as the baby comes out, this closes, etc. And the liver is bypassed, the lungs are bypassed, and there is this opening on the heart. And those 3 things, as the baby come out, there's sort of, you remember, I don't know if they still do today, you tell me, when babies come out, they used to give a smack on the baby. They don't do anymore. But I heard this beautiful story of Rav Jonathan Yeti, and he said when babies come out, they give a slap to make them cry, so that they start breathing and they activate those things. So it's for the baby. I don't know, today they don't do anymore. No, okay, fine. Anyway, so we cannot smack. You can not smack babies anymore. I apologize. I know it's not permitted anymore. Okay, anyway, in the old times they used to do it, and the baby. Imagine being the baby. You are inside, it's cozy, it's warm, and you see from one end to the other of the world, you are learning Gemara with the Malach, you are mamash, Gishmak, Gan Eden. And then suddenly, earthquake, you go through a small tunnel and it's hurting, and then there's this big, huge guy with a white gown that takes you in his huge hands, and then you go, you look, and you need Papa and Mommy and Papa, and they're like this. And then this guy takes his big hand and a big thing on the back, and you cry and it hurts, and he says, not fair, I haven't done anything wrong, no avera, nothing, no chet pesha, nothing, I haven't done anything, and he smacks me. That's not fair. He looks at father and he says, father is going to take his right fist and going to put it in his face, and then he says, the father, toda doctor, chazaku baruch, thank you very much. He says, what kind of a world is this? This is crazy. He said, what do we learn from this? We learn 3 lessons. Lesson number 1, that hurtful things happen in life. Lesson number 2, that even the things that hurt are for our own good. And the lesson number 3 is that eventually, sometimes earlier, if we're smart, sometimes later if we're not, we find out it was for our own good. For example, this kid at age 12 goes to a science class and they say, you know, we smack the baby to activate the breathing so that they can close those three valves. Says, oh, I thought this doctor was a Russian. What a tzaddik, he saved my life. Oh, yo. Okay. Let's talk about another example. We can talk, right? And the voice of male and female is almost the same frequency range. Of course, ladies is a little more higher pitch. And the Chazon Ish writes something fantastic in here. He says, basically, Hashem saw that being deaf-mute would not be nice. So he created a machine that speaks for a person and another machine that listens to those sounds. And what is fascinating is that the mouth and the ears are tuned to the same frequency range. And in fact, it's not pashut, because there are animals that hear on very different frequency range. So the humans are in this kind of 20 to 20,000 hertz is the hearing, ideal hearing, okay? But for example, bats or dogs, they hear ultrasound, and then elephants or other, the ones that do the holes in the ground, whatever, they hear infrasound. There's an amazing story. I don't remember if it was in the 50s or 60s. There was a dog food company that when they did the advertisement for the dog food, all the dogs always came to the TV with their tongue out. And the owners saw the dog and they said, they love that food. I have to buy them the food because they love this food. What was the story? In the sound, they were adding some ultrasound pitches that humans cannot hear, but the dogs were hearing. So when they were putting the advertisement, all the dogs were running to the TV because they heard the pitch that the human was not hearing. This is amazing, huh? And so I want to talk about, everybody says the eye is amazing, and that's true, the eye is absolutely unbelievable. But I'm not going to talk about the eye. I want to talk about the ear, because people don't think about the magic of the ear. So 2 things to understand the hearing, okay? So a sound has a certain amplitude. So for example, I can speak at low voice, or I can speak at loud voice. It's exactly the same message, but the volume goes up, right? Or there are sounds that are low in frequency, the boom, boom, right? What I'm saying. And then there are the high frequency. So low frequency, high frequency, and there is amplitude. Those are the 2 things for sound. Another thing I want to show you, because I'm going to show you a video, this is the ear, and there are a few bones here that are the smallest bones in the human body. So this is, I think, is a dime, and these are the 3 bones, real scale. The whole thing for hearing is this, and in fact, it's really only this part here, the cochlea. We're going to talk about later about this part. So I want to show you a video I've seen a million times, but it's so amazing. Every time I have goosebumps when I see this. I want to show you the video.
The sense of hearing is accomplished by a process known as auditory transduction. The ear converts sound waves in the air into electrical impulses, which can be interpreted by the brain. As sound enters the ear, it passes through the external auditory canal, where it meets the tympanic membrane. The tympanic membrane then vibrates in response to the sound. Sounds of a lower pitch, or frequency, produce a slower rate of vibration. And sounds of lower volume, or amplitude, produce a less dramatic vibration. Higher frequency sounds produce faster vibrations. The tympanic membrane is cone-shaped and articulates with a chain of 3 bones called the auditory ossicles. They consist of the malleus, the incus, and the stapes. The movements of the tympanic membrane vibrate the ossicles, passing on the information of frequency and amplitude. The 3 bones pivot together on an axis shown here in red. The pivotal axis is due to a series of ligaments which hold the bones in place within the middle ear cavity. The anterior malleal ligament
this whole thing is only a couple of millimeters in dimension.
Are of particular importance for the pivotal axis. 2 structures which normally obscure this view of the middle ear have been removed. They are the chordae tympani nerve and the tendon of the tensor tympani muscle. Through the ossicles, the vibrations of the tympanic membrane are transferred to the footplate of the stapes. The stapes moves with a piston-like action, which sends vibrations into a structure called the bony labyrinth.
This thing is a centimeter or so, this whole thing.
The labyrinth is filled with a fluid called perilymph. If it were a completely closed and inflexible system, the movement of the stapes would be unable to displace the perilymph, and therefore unable to send vibrations into the bony structure. Due to the flexibility of a membrane called the round window, the stapes movement can displace the perilymph, allowing vibrations to enter the labyrinth.
I want to make one observation here. This whole cochlea is all bone, solid thing, right? So, and you have 2 points, so you have this liquid inside that we have for hopefully 120 years, right? Inside is something closed. And you have this with a seal that hopefully nothing comes out, right? And then you have this thing which is rubberish that allows its expansion. I don't know if you realize how complicated it would be engineering-wise to just do something of this kind. And of course, just to make it as a joke, you cannot say, you know, for millions of years, men didn't have a round window, so they couldn't hear anything, and then after 100 millions of years, then the round window started, right? So we can make a joke out of it. But the point is, it's amazing that you have some soft stuff inside connected to a whole very hard structure.
The corridor leading to the round window is found within the spiral portion of the bony labyrinth, known as the cochlea. Vibrations produced by the stapes are drawn into the spiral system and return to meet the round window. The portion of the spiral passage in which vibrations ascend to the apex of the cochlea is called the scala vestibuli. The descending portion of the passage is called the scala tympani. A third structure, called the cochlear duct, is situated between the scala vestibuli and the scala tympani. The cochlear duct is filled with a fluid called endolymph, and when viewed in cross-section, the membranes separating the two fluid-filled systems are visible.
This is less than a millimeter, okay?
They are Reissner's membrane and the basilar membrane. The membranes are flexible and move in response to the vibrations traveling up the scala vestibuli.
Another flexible thing inside the solid thing.
The movements of the membranes then send vibrations back down to the scala tympani. A specialized structure called the organ of Corti is situated on the basilar membrane. As the basilar membrane vibrates, the organ of Corti is stimulated, which sends nerve impulses to the brain via the cochlear nerve.
Microns now.
The actual nerve impulses are generated by specialized cells within the organ of Corti called hair cells. The hair cells are closely covered by a structure called the tectorial membrane. As the basilar membrane vibrates, the tiny clusters of hairs are bent against the tectorial membrane, triggering the hair cells to fire. The entire basilar membrane does not vibrate simultaneously. Instead, specific areas along the basilar membrane move variably in response to different frequencies of sound. Lower frequencies vibrate the basilar membrane closer to the apex of the cochlea, whereas higher frequencies produce vibrations closer to the base. This arrangement is known as tonotopic organization. Together, this sequence of events is responsible for our acoustic perception of the world around us.
that amazing? And you have all this in this tiny thing. So this is the cochlea. You remember the high frequencies at the beginning, the low frequencies at the end. Inside you have those little kind of cells. This is, in fact, I saw a picture of someone who did pneumatic hammer. You know, they are on a certain frequency range and very high amplitude. He lost all the hearing in a certain region, which is a certain frequency. So I'm going to say something now for the electrical engineers or mathematicians. What the ear does and the brain is amazing. It's a Fourier transform and an inverse Fourier transform, meaning it takes a signal in time, it separates into frequencies, and then the brain reconstitutes all the frequencies to reform the sign inside. There's a double transformation that goes on between what we hear and how we interpret the sound. It's pretty amazing. And in fact, one thing that is interesting is that the ear has also this other thing on the back that people didn't know for a long time. And in fact, they found out one thing in Hebrew, we say oznaim is the hearing, and moznaim is the balance, the equilibrium, right? And it's only in 1824 that a French scientist figured out that this thing at the back, that they didn't have an idea what it was responsible for the balance. And in fact, Baruch Hashem, that they were not, they say vestigial organs. So they didn't take it out from us before because they thought maybe it's useless. Well, anyway, Baruch Hashem, they didn't do this. But so moznaim, in the same organ, you have the equilibrium and you have the hearing. And I think it's absolutely amazing. And if you can go deeper. I presented in France, there were students that were doing doctors in hearing in the ear and so on. And basically, I asked them how are the sounds processed and recorded? Sometimes we hear a music and it reminds us some memories of because we heard that same music at the same time. It's something that we don't understand yet. It's unbelievable. So we look at all this, and we can only say, Marabu Ma'asecha Hashem. We saw just two small examples, the egg and the ear, but it's absolutely amazing. Hashem is doing something unbelievable. And so I could finish the presentation here, and then we'll go pumped up, but then we go out, and in fact, no, sorry, before that, now I want to pass you back the sentence of Rashi Tzuk. What is nature? Is the modest veil of protection that God spreads over man so as not to force him to believe in God. Think about this. Before you came here, I don't know how much you knew about the ear or how much you thought about the egg, but now you see Eize Chochma that is behind things that we never even thought about. We take it Muvan Me'elav, it's just standard. I'm hearing, it's normal. I never thought about what's going on every time you hear, so that's one thing. So we could end up here. The problem is we go outside, and what do we see? We see things like this. Evolution has been proven beyond doubt. And we have all those proven sequences of fossils that are there. And of course, we have the famous icon of evolution that we see that, we came from the ape and then we arrived there. And then you look at other things and you say evolution has occurred and continues to occur. These are very affirmative statements. And scientists continue to argue about articulate explanations or mechanisms at work in specific instances of evolution. But the fact that evolution has occurred and is still occurrent is undisputed. So you look at this. I want to ask questions only at the end. Okay, thank you. So hold on a second. So he talked about the beauty of the ear and the thing. What kind of thing? So I want to see with you from a scientific perspective. Again, I'm not a rabbi. I'm a scientist. I want to see, is evolution truly a fact or a theory? And let's try to understand what those terms mean, okay? So first of all, scientific method. Linus Pauling, Nobel Prize of Chemistry, said science is a search for truth. And in fact, ideally, it is the search for truth. Some may have distorted this, but that's the point. So you ask a question, you make a hypothesis. And then you check the hypothesis, and you see if the data confirm or not the hypothesis. For example, I would make a hypothesis that if I open my hand, this thing is going to start to fly. Well, it's a good hypothesis, but the problem is as I open my hand, this thing goes down, it crashes, and my hypothesis is null and void, right? Finished. So when the hypothesis is not valid, you have to review the hypothesis. Richard Feynman was a Nobel Prize of Physics. He said there's no theory that is always valid. A theory is only valid until someone proves it's not valid. So everything we have is only valid until we prove not valid. But if you prove it not valid, it's not a theory anymore. You have to change it. So in fact, you have this feedback loop, this red feedback loop. So if the conclusion is it's not supported by the facts, you have to review your hypothesis. Very important point. So is science always true? We sometimes we'anachnu mishtachavim ala scientist, but let's look at carefully. If you look at a Wikipedia list of scientific misconduct incidents, you have something like 10 pages of people who cheated, and those are the ones that we caught. How many we didn't get. When I started my PhD at MIT, I remember a guy who was finishing his PhD told me, listen, don't believe even half of the papers because they say nonsense. So I didn't want to believe him, but I don't know if he was right or not. But I'll give you one example for this guy, a German guy who was working at Bell Labs. Bell Labs is an amazing lab. They invented the transistor. They discovered the Big Bang. Amazing lab. And he was working on transistor on single molecule. Amazing field of research. And he started publishing and published amazing papers. Science, Nature, Nature, Science, Nature, Science, Science, Nature. Amazing papers, one after the other. So when you have a new research like this and you have such amazing results, other groups are trying to piggyback on this research and expand it. So some students decided to take as a PhD to work on this topic. And so they started, and they couldn't replicate the result. And it was not working, was not working, was not working. A bunch of students failed their PhD because they were not able to do the results. Some professors got upset. And they started investigating. What they found out, that let's say paper number 57 had the same level of noise as paper number 13. Noise is a signal that is random, that cannot be replicated even in the same experiment. So that means he cheated on and they caught him. So basically, they had to retract, can you imagine, 32 articles retracted? Eze busha, retracting 32 scientific articles from top magazines. And that was one. Another example, Watson and Crick. Famous, they discovered the DNA, they got the Nobel Prize, so happy. Well, the people who study the history of science know that they stole the microscopy result from Rosalind Franklin, and she didn't get anything, she just died. No Nobel Prize, no nothing. So we need to, Donald Trump would call it fake science. And we need to be careful about that. Okay? An example where, for example, we have to review hypotheses. Newtonian mechanics, the one that you learn at school, sum of force equal ma or equals 0 for statics. And basically with this you build cars, airplanes, and everything we have today is made with this. It's fantastic theory. Beautiful. Newton, by the way, interestingly, he had writings in Hebrew and other things like this. Is a fascinating story. But the question is, if we go very fast or if we go very small, is it still valid? And we know it's not. Because classical mechanics, if we go too small, at the level of the atom or electrons, we get into quantum, which is a completely different thing. By the way, it's a theory that is proven, so far not disproven, but doesn't make any sense. But it works. And then if we go too fast, relativistic mechanics. And then if we go too fast and too small, it's even more complicated. So bottom line, if we are much bigger than a nanometer, and we are much smaller than 300,000 kilometers per second, we are fine with Newtonian mechanics. But if we approach those limits, it's not valid anymore. Okay, so that means sometimes you have some valid theories, but they have a certain field where they can operate and not outside that field. So here we go to Mr. Darwin. So there's the story of the finches, by the way, is a story of microevolution that he extrapolated. We're going to talk about those terms in a second. And it's even a legend. It's not even that. So bottom line, if you go to Wikipedia, you find his picture is like this. This is his picture. And in fact, there is a nice story. There is little Johnny. Little Johnny goes to Daddy. And Daddy, how was man created? Little Johnny. Everybody knows. There was a pond, and from the pond there was a fish. The fish became a lizard. He became a donkey. He became a monkey, and then we came from the monkey. Oh, thank you, Daddy. Thank you, Daddy. And the kid goes to the mother. Mommy, how man was created? Johnny, everybody knows. God created Adam and Eve, and then they had children and children and children. And here we are. But Mommy, Daddy told me that we come from the monkey. Johnny, Daddy was talking about his family. I'm talking about mine. Okay, so let's see what's the problem with evolution. What's the problem? What's Darwin's hypothesis? I'm not calling it a theory, and we'll understand later why I don't. It's a hypothesis. It's called descent with modification, Yerida, right, in Hebrew. Descent with modification from a common ancestor. a process in which species change and give rise to new species over many generations through natural selection, which means survival of the fittest. And given enough time, millions and millions of years, this process generates new species, organs, and body plans. These variations and selections are unguided. That means there's no God, there's no nothing. It's just happened by themselves randomly. So the results of evolution are left to chance. And according to Darwinism, the fittest individuals survive at the expense of the weakest. And by the way, in Shemo v'Zichro of 80 years ago, he read this book when he was in cell. Okay? So, and consequence of all this is that everything happens randomly in many stages over millions of years without the need of a creator. So if you read this, you cannot be a Ma'amin because it's a stira in itself. So I wanted to understand scientifically what's true and what's not true, because some things of evolutions are true. We're going to try to understand what they are. And so according to this, the consequence, the tragic consequence, and this we see on our generation, a tragic consequence of it, that many is just an accident, or rather a series of innumerable accidents, and therefore no more important than a ground worm. And that's because they're just made of atoms and they have 90% plus DNA, the same thing. So there's no difference between us and the worm. And so basically the chashivut of human being is gone with this. So everything we saw before, the precision, the ear, the thing, goes all down to the garbage, right? All the appreciation we can have. So we need to understand this, and we need dama mashetashiv la pikoros. We need to answer the pikoros. In fact, the Rav Avigdor Miller said that the Alter of Sobotka said, who is the pikoros? The pikoros is ourselves. Sometimes we have doubts. We see things that are terrible that happen. You know, we saw some terrible things this last year. And sometimes we have questions. We don't understand. So we need to know how to answer to ourselves. So let's have a look. And it's such a topic that causes serious fights. This guy is a professor of physics at Ball State University. And a very average, I don't know, it's not one of the top universities in the US. And bottom line, he was teaching a course where he was making the students think about how come all the constants of physics and chemistry are all well designed, and etc., etc., etc. Which means, and he had even atheist students that were drinking his words and discussing with him and stimulating their thinking about, wow, it's amazing, the world is an amazing place. And in fact, there was a professor who gave him such a hard time, professor who was some 400 kilometers away from him. He gave such a hard time, they almost fired him and they asked him to cancel his course. So he wrote this book, Cancelled Science. What some atheists don't want you to see. And when he says atheist, who is it? Mi hu ze ve'eze hu? Jerry Coyne, a Jewish guy. That's a biologist that when he heard that there was a course successful that was not into the evolution thing, he gave him such sarod, he was almost fired, this Eric Hedin. Okay. Another example, there was, that was in 2004, there was a lawsuit of 11 parents because a school used to present both evolution and intelligent design. So they made a whole fuss, they brought experts and so on, and then they had to write, you know, rules of how to teach. And bottom line, the holding of the corrupt judge in there was teaching intelligent design in public school biology classes violates the establishment clause of the First Amendment to the Constitution of the United States. Because intelligent design is not science and cannot uncouple itself from its creationist and thus religious antecedents. Chalila vechas, that you mention God in the science class. In fact, interestingly enough, if you look at history of science, the first scientists were all religious. They were all priests, right? Science and religion was very much together. It's only Darwin and there. One thing I want to say, I heard from Rav Avigdor Miller something beautiful. Why Darwin came on the scene? Why Hashem sent Darwin on the scene? He said something beautiful. You know, he came on the scene when science started to explode. Today we have electronic microscopes. We understand science at a level that is unprecedented. And we see mamash, when you look at it, you see the hand of HaKadosh Baruch Hu magnified much more than people could have done in the 1800s. And he says, if we didn't have a Darwin, we wouldn't have Bechira anymore. Because it would be so evident that there is a creator. When you look at science, we needed a Darwin to bring something else so that people can make a mistake. Unbelievable. This is Rav Avigdor Miller. Okay, and it's such a hot topic, there's lots of cheating. For example, peel-down men. They found someone brought a skull of a human with a jaw of a monkey, And the whole thing was very unbelievable. After 40 years, they figured out it was a fake. The guy put them together. He put them in some acids and made some heat treatments to lock them. And he kind of cut some of the teeth and things like this to make it legit. And bottom line, it was a fraud. Another one is the peppered moth. Peppered moth was this moth. You know, sometimes you have those kind of flies. We had a lot on the sukkah this year. I don't know why. Those moth that are in there. And in England, when there was the Industrial Revolution, and it was very dark and polluted and so on, they became black. So they said, evolution in action. And they have this famous picture of the moth on the tree, the black moth on the tree. A scientist who studied moth for 40 years said they never go on trees. They go only on branches. They never go on trunks. They go on branches. Bottom line, it was a fake. And those things are still in biology books. That's the worst thing. Haeckel's embryos. Haeckel designed the embryos in a way to show evolution, but he didn't design them properly, and they figured out it's a fraud. But what is fascinating is that these things we know are fakes, and they're still in biology books, which, by the way, most of them are written by Jewish scientists. Kenneth Miller and other things like this. Okay. And if you start talking about intelligent design, you may get in trouble. There is this guy, Dr. Richard Sternberg, was a scientist at NIH, and he was the editor of Proceedings of Biological Society of Washington, and he allowed an article by Stephen Myers on intelligent design, and they made his life so impossible he had to resign within 6 months. So his career was finished. And in fact, you may wonder, in the scientific world, why professors don't protest about this. In fact, there is a group of professors, but they are a small amount. Why? Because they're afraid. They're afraid because it's something against the establishment. I want to show you one example that is unbelievable. So usually, only full professors take a risk to disagree. Baruch Hashem, I was promoted full professor not too long ago, and now I can talk about this. I didn't dare to do it for a long time. So the story is, there's this professor, Michael Behe. He is a proponent of intelligent design. He wrote beautiful books. Very chashuv scientist. And he works at Lehi University, not one of the top universities. But look at this. On his website, he has a disclaimer. This basically says, this research that you are doing is the one of my lab. My department is not agreeing with me, and the university does not agree with me. Imagine you work in a company. It says, my boss doesn't like what I'm doing, and my company doesn't like what I'm doing, but I'm here. Nobody can fire me. This is what it works, right? Okay, this is what's going on. Okay, Rav Moshe Averik Zatzal, he wrote a fantastic book, and in fact I was zocheh to attend his I think it was the last time he made this seminar on this, and he gave me beracha on the book of it, and I learned so much from him. And I want to show you something from his book that is so amazing when you think about this. Let's have a look. He says there are two critical points of confusion. Point number one, contrary to popular belief, nobody disagrees about the existence of very high levels of design, functional complexity, and specified information in the living world. We'll present ample evidence of this. Okay? And point number two, so everybody agrees that the ear is super complicated, right? Nobody says, it's pashut. No. Everybody agrees that. Second, contrary to popular belief, nobody disagrees with the argument from design, including every atheist and skeptic in the world. It means he said the suit proved the existence of the sailor, a poem the existence of a poet, and the watch the existence of a watchmaker. And the suits, poems, and watches don't make themselves. And in fact, there is no one who disagrees with the fundamental laws of physics and mathematical probability that are behind the truth of these propositions. So the question is, where do they disagree? If they don't disagree on the complexity and don't disagree that things don't make by themselves, where do they disagree? Well, he says this. He says the point on divergence is that the atheist or non-believer argues that the argument from design cannot be applied to the world of living systems, that it does not apply to the design observed in living organisms. So for some reason, design applies everywhere except in there. So let's have a look. One thing I want to clarify, and this is one of the most important slides on this topic. People say evolution. And with evolution, they explain everything. They explain the Big Bang, origin of life, and all. No. Hold on a second. There are different things, and I want to clarify the terms. One is called origin of life. You may have heard about the experience of Uri Miller. He took some gases and exploded them, and he found one amino acid. And he said, you see, from there you can have a mixture, and you can get life from it. So basically, it's like saying, I make an explosion in a junkyard, and I find one nail. I say, you see, I can make an airplane from this, right? Okay, that was the thing. That's called origin of life. The second is called macroevolution, the one that we see, the fish becomes a lizard and becomes a monkey and becomes a man. And then there is something called microevolution, like for example, different space of kinine or other things. We're going to talk about this. So I want to start with the microevolution. The microevolution is the one that is true to some extent. And in fact, organisms can adapt and can in a limited way evolve. Example, antibiotics. With antibiotics, we see examples of microevolution. I want to show you one example of microevolution that I found very interesting. I don't know if you know this guy. This is a very nice guy, but we cannot say he is a very fit guy, okay? So let's send him to do 2 years of bodybuilding. And after 2 years of bodybuilding, we find out that he became like this, okay? So are we saying that he evolved? Well, that's microevolution. I can practice piano for 5 years and I become a concert pianist and I have microevolved. No new organs, no new nothing. It's just microevolution. I stay in the sun too long and I have dark skin and my kids will have dark skin. Microevolution. In fact, let's see one thing, but because even in microevolution, we need to be careful about mistakes in thinking. Let's take one example, DDT and mosquitoes. When they came up with DDT, an insecticide, it killed all the mosquitoes. And then suddenly they reappeared. And they put the DDT again, and it was a little less effective. And then they came back again, and it was even less effective. Oh, you see, they evolved. So now let's think about the possible options. One option is adaptation, genetic mutation. That's one option, right? We can say one option is that. But think about this. Couldn't it be just the elimination of the weak? So on mosquitoes, you have strong mosquitoes and weak mosquitoes, right? When you put the DDT, you are killing all the weak mosquitoes, and the few strong remain. With the few strong, we'll have strong kids, right? And so the next generation will be stronger. Then you do it again, you again eliminate the weak. So at the end, you end up with, so Imach Shemo v'zichro, there was a short guy with mustache 80 years ago who wanted everybody to tall, blonde, blue eyes, right? You remember this guy? Well, let's assume he had his way. And then you look at the fossil record and you see there were a bunch of tall guys, fat guys, nice guy. And then after that, all blonde, blue eyes. Oh, evolution. No evolution. It just killed everybody else, right? So that's one interpretation. So we need to be careful about this. And the third is what is called epigenetics. It's an interesting new science that basically says that in the DNA, you have parts that can activate or not activate themselves and can be even transmitted through reproduction. So it's something that is already programmed in us. HaKadosh Baruch Hu made us with already the programs ready in case something needs to be done. Unbelievable. So, and in fact, it's supported even by Gemara. If you look at the Gemara, you remember the story of Hillel, the guy who wanted to make him angry on Erev Shabbat, and he goes, Hillel, where's Hillel, where's Hillel, where's Hillel? I have questions. One of the questions was, why are the Talmudians' eyes stretched? And he answered, because they live among the sands. So when you live among the sands, you have wind, you don't want the sand in your eyes, so you squint your eyes. So they squint the eyes, and they ended up being a population of squinted eyes. That's microevolution. No new organ, no new body part, no nothing. And then he said, why the feet of the Africans are wide? Because they live in the middle of the marshes. So what does it mean? So well, it's good to have large feet to swim, right? So that's not the problem. So these are examples of microevolution. We don't have any problem with that. Macroevolution. Now remember, I said to you, a hypothesis can become a theory if you don't have any steer against it, anything against it, right? So is macroevolution true? Well, let's have a look. So first of all, we need the missing links. We never found, despite 150 years of digging, millions and millions of fossils, we never found a single series that makes any sense. Not a single one. Not a single series that makes any sense. And even the ones that they say make sense, really they don't make sense when you look scientifically very, very carefully about it. Second, something called the irreducible complexity. The guy I showed you before, Michael Behe, is the one who came up with this. Irreducible complexity is a concept where basically a system cannot work without all its parts, and any of its parts doesn't make any use on its own. For example, we have a cardiovascular system and we have a respiratory system, and the two work together. We breathe, we oxygenate the blood, and the blood circulates, etc. Can you imagine, for millions of years we didn't have a respiratory system, only a cardiovascular system, and after 100 million years we had also the respiratory. That doesn't make any sense. Doesn't make any sense. There are things, for example, coagulation of the blood. It's something like a dozen of enzymatic processes on cascade, one after the other, and you need all of them to happen. And if one of them is missing, a guy who has a scratch, he will die by losing all his blood. Because you need all of them to be there. So that's called irreducible complexity. Because that goes completely against evolution. Because there's no evolution. It's something that should have been there from day one. Third, inversion of geological layers. You need to find, from a geological perspective, the evolution should show that there is complex species on the surface, and then the more you dig down, the more simple the species are. Because they were simple, and then they evolved into complex. And we find everything upside down, sometimes the complex down, and even there's another one called Cambrian explosion. It's a layer of very short geological time, in geological timings, and there you have hundreds of complex and simple organisms that appear at the same time, exactly against the, by the way, when they discovered this, they hid this for 40 years. And after that, they rediscovered them because it's a big problem for evolutionists, this thing. This is a proof total against evolution. Complexity of DNA. When Darwin came up with this idea, which, by the way, he was kind of honest, in the sense he said, it's a hypothesis, we need to prove this and this, and we never proved it, but we made it true anyway. The complexity of DNA is like 100 million pages of the British Encyclopedia in terms of instructions. And when they said, you know, we need 5.4 billion years for the evolution and things like this, they thought that the cell was a protoplasm. There was nothing special in it. Now the DNA is breaking everything because, and we know, by the way, the DNA is like a computer program. And computer program, there are laws very well defined. On a computer program, when you do a modification random, the chance of improving the program is 0, right? And when you apply this, you need that you have a problem. Another thing, probability of growing even a single organ is practically 0. So one thing that really makes me upset is that in the field of medicine, when they publish, for example, a new drug, is it effective or not, they have some very strict statistical standards to prove that it's effective, or it was not a placebo, or it was not this, etc. But when it comes to evolution, I have a thing that I can say, yeah, it has a chance in 10 to the power of 200 to happen, and then it's fine, the paper will be published. Hold on a second, it's like saying, if I tell you that for a year, I'm going to buy one lottery ticket of all the lotteries that go on the world, I'm going to win them all, with one ticket of all. You're saying impossible, right? But this is much less probability than what they're publishing out there. So how come this is accepted, and if I tell you this, it's not? So this is something then, and people usually, people are not going to go and look at the scientific papers to understand this, but when you do, you will figure out that there is this going on. All these problems have led to several modifications of the initial hypothesis. Now, the punctuated evolution of Stephen Jay Gould, and then they call it neo-Darwinism, and they don't even know, we don't even know exactly where they are in terms of modification of the initial hypothesis, because every time there's a problem with that. Vestigial organs. So for appendix, we take out the appendix, right? They figured out right now the appendix fights infections, and also it's a good place for some very beneficial bacteria to be there. And they found out that people that had the appendix taken out, they suffer from some diarrhea thing and other things like this that otherwise they wouldn't have. And there was a scientist, one came and he presented this picture. You see, the tail, baby with a tail. And they made a whole thing, and he argued and so on. And he didn't know that the image was photoshopped. So then after that, he apologized for the image Photoshop, but he continued keeping his point that the cock is a vestigial organ and so on. When I was little, I had some problem with the throat, and then I found myself in the hospital taking the tonsils out and give some ice cream after that. I remember I had a very nice thing with the stickers of dinosaurs, all things, right? And this is what they were doing. Today we don't do it anymore. We realize that the tonsils have a certain function, right? Junk DNA. There are some parts of DNA that they don't understand, so they say they have no function. This is one thing we need to be careful. Just when I don't know something, I should say I don't know something. I should not say it's useless. If I don't know what it is for, I don't know what it is for. But maybe one day we'll figure out what it's for. So many times they've said this is junk DNA, and they figured out, they thought that the junk DNA was a certain percentage, and this percentage has been shrinking and shrinking and shrinking over time. And then another thing, when you talk about this, according to Darwin, there are things that are accidents. Like, for example, wings. Wings is an accident. How come they grew wings? So it's already a freaky accident that, for example, one species grow wings. But when you grow across different species, that's even more weird. For example, insects and mammals, bats are mammals, insects and birds, the three have wings. So you had the same accident happening across 3 species. And then there are so many circular reasoning, cherry picking of data. For example, they have a bunch of data. You know, there's a joke they say in science. They say typical results. You know what typical results means? I did the experiments 200 times. It worked 3 times. I take one of those 3. And I say typical results. Right? This is called cherry picking. Circular reasonings. So for example, homology. Homology means when you look, for example, at the hand or the leg of an animal or the wing, they have kind of similar type of bones, even though arranged separately there. So they say homology can be defined in terms of common ancestry. Because we had common ancestry, therefore we have homology. And then just on the same sentence they say an homology is used as an evidence of common ancestry. So this is circular reasoning. So you see, ancestry is because we have ancestry, we have homology, and homology is a proof of ancestry. This is in the same sentence of the same biology book. And then what I call the intra-hypothesis contradictions. So, stira mine ube, for those who learn Gemara. For example, we say that evolution is a very slow process over millions of years, and we say survival of the fittest. But when you think about this, it doesn't make any sense. Imagine a fish, and he grows 1 leg. And this, do you think a fish with a leg is the fittest? Misken. A fish with a leg is a misken. And then he has to wait another 100 million years for another leg, and then another 50 million. But what is this nonsense? Ravi Miller says it's like you have cats, and they don't have there's pus coming out for the little cats, no milk. And then for 100 millions of years they are sucking pus, and then eventually, evolution makes it becomes. What is this nonsense? You have a stira mine ube between a very slow process and by the way, in chemistry, many times a slow process doesn't help in here. So too many contradictions for calling it a theory. That's why macroevolution so far is disproven. Origin of life is even worse. Life, one thing that is, by the way, when they say evolution shows origin of life, this is where it gets really out of hand, because this is quotes from evolutionists. Life must have preceded evolution. We know much more about evolution than about origin of life. That means that evolution cannot explain origin of life. Evolution starts after origin of life. So you cannot say evolution explains origin of life. So this is the misnomer. So when they say this, it's total nonsense. And I think people are stupid. And the people, unfortunately, don't pay much attention to this. And this we need to pay attention. And listen to this. This is another evolutionist. A succession of extremely improbable passages is essential for the origin of life. This makes the final result almost like a miracle. Cannot say it's a miracle. It's almost. He's not the first. Francis Crick. By the way, I told you that he stole the microscopy from Rosalind Franklin. So listen to this sentence. An honest man. So, an honest man. An honest man, armed with the knowledge available to us, can only say that in a certain sense, the origin of life appears at this moment to be almost a miracle. Right? Again, he's almost a miracle. By the way, he came out at the end of his life. He came up with a paper on panspermia, meaning that there are extraterrestrial beings that brought life on Earth, and they almost did not accept the paper. But can you refuse a paper of a Nobel Prize like Francis Crick? So they accepted the paper to show you how. But not everybody is agreeing. There's a Professor Jim Tour at Rice University, a very strong chemist. I know him personally. And he criticizes those public scientists and he says, it is clear chemists and biologists are ignorant. And he's challenging them big times. So but the problem is, to understand him, I don't understand all the chemistry he's doing. It's very, very, very advanced chemistry. And he's basically destroying them. Okay, so bottom line, origin of life is nonsense. But let's see a little more. Professor Harold Morowitz of Yale has calculated the probabilities that a bacterium, which is the simplest living organism, can assemble in itself. It's 1 in 10 to the power of 100 billion. 1 in 10, okay, no, but I want you to understand. In the entire universe, we are estimating that there are 10 to the power of 82 atoms, right? And I want to, what is 1 to the 10 or power of 100 millions? I want to show it to you, a real life demonstration. I'm going to have now a program, I did a program. it will write for you 100 zeros per second. Are you ready? Ready. 3, 2, 1, go. 0.00. Here we go. 100 zeros per seconds. We're going to go to 100 billion. Right? Well, I stopped it. Why I stopped it? So I cannot, there's no room for writing them all, first of all. I wrote only 600 zeros. Only 600, not 100 billion. Why I didn't write 100 billion? Because otherwise Rav Hatzera would be very upset. Because it would take something like 32 years to write 100 billion zeros at 100 zeros per second. Okay? So you understand the logic, you understand how, and this is for a bacterium, right? Not for a human being. This is for the simplest form of life. And the universities keep on hiring people for just proving that origin of life can be done without a creator. So anyway, this was what I presented. There is a website where I have done a lot of videos on different sides of science, things of science. It just has a little problem. Is you need to learn French before. It's called Torah Box. And but that I have a couple of videos that are in English. And if someone is interested in being a video editor or helping to kind of redo this series in English, please talk to me. Of course, after you have given all the money to Mamloes first. After that, if you have extra money after Mamloes, then we can talk. And very important people are watching my videos. I want to show you. Even people going to learn French to just see my video. Look. Oh, the thing doesn't work. Okay. So anyway, he's watching my videos. Who is he? Bibi. Bibi. This is Bibi. That's Bibi.
You know French?
Yeah, he learned French for this. So we... As a professor, I had to say something fake at the end. So we know it's a mad world. There are crazy things going on, but when we see that there is plan and purpose, like Rav Victor Miller says, there is plan and purpose in everything, in every aspect of recreation, we understand that it's a wonderful world. So thank you, Hashem. Toda Rabba to everybody. And now Rav Victor Miller would say, and questions on any subject, but I put a proviso with no guarantee that I can answer. And if you are interested, there's this email, which is magic, because it works in French and in English. Science613miracles@gmail.com or science613miracles@gmail.com. Okay. Ah, yeah.